Hello and welcome to another CinCraft scenario tutorial. I'm Abel, Product Specialist at ZEISS. Today we're going to run through the new feature in CinCraft Scenario, the lens calibration template fine-tuning. First, what is a lens calibration template and how does it enhance your tracking workflow? So using a ZEISS lens is simply plug and play with our system. Just select the ZEISS lens from the drop-down list and you're ready to jump into the next steps. On the other side, for third-party lenses, it is a bit different. So let's take a look. For the use of third-party lenses, we have implemented the so-called lens calibration templates. With this feature, you can select from a vast variety of pre-calibrated spherical lens templates, which makes it a lot faster compared to a full manual lens calibration. You can easily select the needed lens in our drop-down menu and start with the fine-tuning process. Here, you adjust the selected lens template to your specific lens that is mounted to your camera. In case of mixed lens projects, this gives you much more versatility. You can add all of your needed lenses to your equipment and then easily switch between them. So whether for broadcast or cinema projects, you gain a lot more flexibility. In a few minutes, you're able to calibrate third-party lenses with the help of our lens template fine-tuner. So let's check it out step by step. We start on the equipment tab. Here you add your camera setup as always. Now having one camera, you simply click here to add a new lens. As you can see, this has changed a little bit. Now you can select between a VLP, a lens calibration template, or a manual calibrated lens file in case you're upgrading from a previous system and want to carry over your calibrated lens files. When you select a lens template or a manual calibrated lens file, you can give the lens a nickname or an ID to help you identify it. Then you select the lens manufacturer, the series, and here the model. To showcase, I'll add this one right here. I'll also add a manual file and a VLP. So back in the equipment tab, you see all three lenses we added right here. The two third-party lenses will show a notification indicating that these lenses need to be refined. Scenario will show this for any third-party lens that is not part of the ZEISS VLPs. It is an indication that you should and must check the specific lens again to ensure that the lens calibration is complete and correct. To do this, click on the notification and start the lens fine-tuning of your template. At the top, you will see each step that is needed: lens encoder, center shift, cam bar alignment, set 0 point, and refine calibration. Before starting, you will be guided and advised to set up the camera and environment in a certain way. Put the cam bar on the camera with no rotation and facing directly forwards. Put the camera on a tripod or rigged so that you can easily pan and tilt. Have a tape measure and make sure the environment has some natural tracking features within it. Do not do it facing a large green screen, for instance. First, we verify the lens encoder's functionality. To do this, we look at the values and slowly rotate the lens barrel from hard stop to hard stop. Try to cover the whole range of motion at least 2 times. At your minimum object distance, the encoder value must be at 0, and when at infinity, it should be at 1. This is particularly important if you're using the CinCraft external encoders, as they may need to have the range inverted or completely reset to make sure that they're correctly in sync with the lens movement. If you are doing a zoom lens, then you will need to do the center shift calibration. Here we determine and compensate the offset between the optical axis of the lens and the center of the sensor. This is designed to remove any drift that can happen on a lens when zooming in and zooming back out. In the case of a prime lens, this part can be skipped. For this example, we're using a zoom lens to show you the entire workflow. So, you look for a specific target in your environment, and then you zoom fully in on the target and then zoom fully out. If the target and the overlay are shifting, you need to adjust it until it fits perfectly. You can then zoom in and back out to check if that alignment is correct. Now you need to physically measure the distance between the cam bar and the main camera sensor along the Z and the Y axis. After measuring, you enter the values into the UI and then do the cam bar offset procedure. For this, you must place a calibration graphic within your environment. This is done by aiming the camera where you want it to be placed and then pressing this button here, like aiming a scope at a target. Once this is done, a grid will be displayed that is aligned to the camera and stuck to the spot that was chosen in the step before, so that when you pan and tilt the camera, the grid stays in a fixed position. Now we see the refine interface where we can see all of the calibration points that are available to edit. You need to go to each calibration point by adjusting the focus and the zoom, and check them individually by doing tilts and pans with the camera. Now you observe the movement of the 0 point. If the CG grid looks good at that fixed position, then you can move on to the next one. If you see the grid sliding or not distorting correctly, then you can adjust a focal value that will make a small adjustment to the grid position. In a later version, you will be able to activate an option to display more values such as the K1 and K2 values and optical center details. Once you have gone through all of the calibration points and you're visually happy with your results, you can now save this calibrated lens template and exit the process. This lens is now considered as being ready to use, and one more advantage, once you've saved it, you can reuse it anytime that this configuration is loaded. For more information, please visit our website. Thanks for watching this tutorial, and we'll see you in the next video.